tell us your name and tell us about your project.
My name is Edward Williams Morley, Professor of Chemistry at the Western Reserve University, and our project was the Michelson-Morely Experiment. And in this experiment, we reflected a light off of a partial silver mirror. This mirror split the light and projected it onto two mirrors. These two mirrors we held in place on perpendicular arms that were exactly equidistant from the partial silver mirror in the middle of the apparatus. The light reflected off those two mirrors is then returned to the partial silver mirror, which reflects it back to our detector. The detector is then able to determine whether these two returning lights arrive on it at the same time or different times. And it does this by measuring the light fringes as they reach it.
What were you guys trying to do or find?
We sought to measure the relative motion of the Earth, and we were doing this relative to the stationary median of light, the stationary median of course being the aether. And to do such, the two arms of our apparatus were spun round while it's in place. And as it spins round, at some point in time, it should be one of the arms should be parallel and perpendicular to the relative motion of the Earth. And as they are parallel and perpendicular, the speed of light should change as the two arms are perpendicular and parallel, because the Earth is moving through the median that the light has to move through at the speed of light.
Where did the project or experiment occur?
We conducted this experiment in 1887, and in the basement, it was all done in the basement of the Adult Dormitory of the Western Reserve University, all in Cleveland, Ohio.
What other significant events were happening around this time in the world?
Well, 1887 was a big year. The French and the Germans nearly went to war over a border dispute, and that was the same year the French started their first work on the Eiffel Tower, at the time the biggest building in the world, and the U.S. Navy started stationing ships in Hawaii.
Who else was involved in this project?
Well, I conducted this experiment with Albert Abraham Michelson, and he was an incredible physicist, and he studied the aether and the speed of light quite intensely. And this experiment, in fact, is in many ways a more complex and accurate version of his 1881 experiment. However, the complex preparations and work required for this experiment proved so strenuous on Michelson that he suffered a monumental breakdown in 1886, which delayed our work until his recovery.
What was your role in the project?
Well, I joined Michelson's work around 1885, and my part in the project was to improve upon Michelson's design and increase the accuracy of our data. And in this effort, we constructed our apparatus beneath the adult dormitory with its strong walls, and to reduce the vibrations and allow the apparatus to rotate freely, we built a lowered sandstone trough. We then filled this trough with mercury and flowed the apparatus atop. However, even with all of this, every time that there was a thunderstorm, or every time a horse would walk by, there would be vibrations that would throw off our light fringes, leaving us to have to wait until the device settled, until we could get an accurate reading.
What impact did your project have on the physics community?
Well, despite their efforts to call this the most famous failed experiment in history, it provided incredible insight into the nature of the aether and of light. As the results showed, the movement and orientation of the Earth and the orientation of our device held absolutely no relation to the speed of light within the apparatus, and this refutes the idea of the stationary aether and the Earth moving through it to produce an effective aether wind.
Does this experiment disprove the existence of the aether in your opinion, Mr. Morley?
Not at all. If this experiment proved anything, it proved that there's a lot more work that needs to be done on the nature of the aether and how light travels through it, and how it interferes with matter and its movement.